Hey there! Today we're going to be learning about conditional probabilities. For example, the probability that it's going to rain tomorrow, given that we know that it's going to be sunny. Now, maybe you already know that it's sunny on 3 days out of 4, or that it rains on 1 day out of 5. But how do we combine that information to figure out the probability of it raining, given that we know it's going to be sunny? This is where conditional probabilities come in. It doesn't take a genius to realize that sun and rain have some kind of relationship. If you see that it's sunny outside, you're much less likely to expect rain. And if you see that it's cloudy outdoors, you're much more likely to bring an umbrella. But that certainly doesn't mean that you never see a day where it's sunny outside and then it also rains, or a day when it's cloudy outdoors, but it stays dry. And this is the magic of conditional probabilities. They give us a way of talking about situations where the probability of one thing might be dependent on the probability of another. We're going to explore this visually using something called a probability square. That's just an empty square, I hear you say. And yes, you're right, it is just an empty square, but it's going to visually represent for us the entire universe of things that could possibly happen. The probability of some event occurring is going to be represented by the proportion of the probability square that it takes up. So this event, doesn't matter what it is, takes up half a probability square. That means the probability of it occurring is 1/2. Imagine we're trying to predict tomorrow's weather. To keep things simple, let's pretend there's only two really clearly defined options. Either it's going to be cloudy or it's going to be sunny. At the same time, we're interested in whether or not it's going to rain. Again, let's assume that there's two really clearly defined options. Either it rains or it doesn't. The special trick of conditional probabilities is that we can break down each of these probability squares into its subsections and get probability rectangles that behave in the same way. In our case, first, we erase the clouds, wish I could do that in real life, and focus just on what happens on sunny days. The probability of rain on sunny days will be quite slim. Rain only takes up a very small proportion of the sunny probability rectangle. We could also go back and isolate cloudy days instead. We erase the sunny days and then examine the probability of rain on cloudy days alone. The probability of rain on cloudy days is going to be pretty high. It takes up a pretty big proportion of the cloudy probability rectangle. Finally, we can stick the two pieces together and see the big picture all at once. The overall probability of rain is still given by the proportion of the square in general that's covered in the dashed blue lines. If that's not the same as it was in the original drawing, we've done something wrong. You can't tell just by looking, but I promise those areas are equal. But breaking it down into the conditional probabilities adds a lot of useful new information for us. Now, in a normal statistics class, you're much more likely to see conditional probabilities written out in words rather than represented in pictures. In writing, statisticians represent conditional probabilities with the conditional probability bar. For example, this phrase means the probability of rain given sun. Let's break that down and see what every step means. First, we have the P with the parentheses. That just means the probability of whatever we have inside the parentheses. Next, we have our first event, in our case, rain. This just means that the topic of discussion is whether or not it rains. After that, we have the conditional probability bar. This just means that we're looking at the probability of seeing the event on the left-hand side, given that the event on the right-hand side has occurred. Then we have our second event, in our case, just whether or not it's sunny. When we put those together, we get the phrase rain given sun. This means it rains on a day which is sunny. Now we can answer a simple conditional probability question. Suppose someone asks us, what's the probability it'll rain tomorrow, given that we know it's going to be cloudy? Well, we simply break up the big probability square and examine what proportion of the cloudy rectangle is covered in rain. In this case, it's pretty clear just by looking that 1/2 of the cloudy probability rectangle is covered in rain. Therefore, the conditional probability of rain given clouds is 1/2. And now we're done. What's the probability of understanding conditional probabilities? Given that you've watched this video, I hope it's pretty high. See you soon.